Um, Hello and good morning, everyone. I'm Shala and I'm from PCCW Global. I'll be giving a very quick presentation on our network and our network as a service, Console Connect. So I would like you to imagine today if a service provider has the world's largest IP network and we carry approximately 20% of all of that traffic across our network. Imagine if you were able to harness that and make that as part of your own network. So if you're doing internet on demand, if you're sending traffic across regions for end runs or even global runs, and if you are able to harness that if you're able to harness that power for yourselves and for your networks. Can you imagine that in terms of traffic and capabilities and as well as bandwidths, these can belong to your networks today. So you are basically getting an enhancement of your own end-runs capabilities. You are extending that reach all the way into your network, your own networks today. So PCCW Global can actually help to do that. And how? It's okay. Yeah, no need. So the Console Connect platform basically combines about 1.3 million lines of code with our own global network infrastructure. So if you were to bring this platform in or this network as a service into your own networks today, you are actually riding on that IP network that diagram that I showed you earlier. Basically, you are getting an extension of that same IP network today. Okay, I'll just quickly run through. The rest of it is pretty much just statistics and diagrams. But ultimately, what you're getting is, again, I'll show this diagram. This network shows you the extent of your reach, your capabilities for your own universities, your end-runs or R&D labs, etc. Just a quick update on some of the cables that are actually going live fairly soon. PCCW Global actually owns one of the largest submarine cable networks today. And these are some of our on-net cables. They are about to go live or already are live in this quarter. And we will be delivering some of these bandwidths fairly soon. And if you are looking to connect from Asia to the US, or from Asia to Europe, or even from Europe to the US, across these submarine cables, we will be able to actually deliver them on these networks today. Why we are doing this as a network as a service, basically, so we have the submarine cable networks, we have the IP networks, but traditional networks are typically not the usual. A lot of telcos actually are moving into technology. And this is one of the reasons why we have actually built a platform called the Console Connect over and above our own layer 1, layer 2 networks today. And we are delivering it via a very simple user interface back to all of you. So today, enterprises or even people who are using networks today are actually changing. More of their mission critical information is actually being put onto the cloud. And we are able to give you that connectivity to the cloud so you can do more and do more complex, computing, or even have high bandwidths, are able to actually turn up and turn down bandwidths or speeds, and have a no contract term, basically, for this. So what we are able to do is give you a connection to a private network, which is the existing submarine and IP networks that are already on our platform today. We are able to give you a connection to that. We will also allow you to connect to cloud service providers. We will also improve network efficiency. So you are not bound by contract terms. You can pay as you go. And I think this is especially useful when end-runs are doing certain projects or delivering certain data that is maybe may not be critical, but it could be very large packets. So we can actually give you the access such that you can turn up and turn down bandwidths as and when you need. Okay. Okay, so I mentioned earlier what Console Connect can actually do. We will give you access through one port. We will be able to give you access to cloud service providers, other software as a service providers, data centers, internet exchanges. I think this may be of particular interest because internet exchanges today don't have an immediate ability to actually connect to smaller universities, smaller academic entities. Today, we will be able to give you that access to these internet exchanges around the world through our platform. Okay, and this growing ecosystem will also allow you to connect to other business partners. When I say business partners, it may not necessarily be someone who is in the software as a service, or or a security as a service provider, but it could also be certain corporations or enterprises that are on our ecosystem, and you are looking to do some kind of activity or business, or maybe even a simple cross connect with them because you are actually exchanging data among yourselves. Okay. You can see that this console platform is already pre-configured, patched, and ready to go in all of these data centers today. It's not where you come to me and you place an order, for example, and you want to actually have access. No, these are already pre-patched. All you have to do is just buy a port and you're already in those data centers. And these are all connected on the same network. AS3491, that is our AS, our IP AS. And as long as you're on a single AS with us, all of your routing is kept within the network. You do not leave the network. It basically stays within our network, so you don't have too much latency, and it's literally a next hop away. Okay, these are some of the logos I mentioned. Cloud providers, we are already connected to all of these. Okay, so if you're looking to do connectivity or any type of public cloud hosting, these are the cloud providers that we are already on board with. These are our software as a service provider. Some of these logos may be familiar to you because you're already doing projects with them, for example, for your own institutions. And these are the internet exchanges. I believe this will be of interest. These are the internet exchanges that we are already on board with today, and we are looking to grow more or add on more to this network. So ultimately, what we are saying is that we are actually connecting to you to an existing global ecosystem. This is not new. Console Connect has been around for a while. And because of this, we have actually reached almost 1,000 data centers and POPs today. So these are the partners that we have I've mentioned. They are already on board with us. Just a quick recap. So this is all given to you through a simple registration and one port, sorry. And this port can be a 1G or a 10G. And simply through one port, you can actually do multiple VLANs. So you can connect to different, let's say if you're buying a 1G port from us, you can actually splice it up and give maybe 500 meg to a cloud service provider, another 500 meg to, for example, another ecosystem partner. So you can actually break up that port and do multiple things with it. And this is a flex bandwidth, meaning to say you can actually turn up from 1G to 10G on the fly. You just have to log into your portal and change your port access and upgrade it. And if you need it for a short duration, you can actually put in a specific amount of time that you need it for, and it will actually turn it down after that duration is over. And you're not bound by any contract terms. The only contract or only term is required is for the port access. You keep that live, you keep that open, you can actually flex up and flex down as long as you need, as fast as you need. So imagine you probably do a lot of online shopping. It's as simple as that. You basically open, this is through an app. It's available on your mobile phones as well. You can register, turn on the app, and you can place orders through that app. So you imagine you're ordering a point-to-point circuit between Singapore and Hong Kong on AAE1, the cable network. All you have to do is turn up a port in Singapore, turn up a port in Hong Kong, and buy a 1G L2 connection between the two. And if you need it for 1 month, you can just subscribe to it for a month and turn it back down again. So the only thing that is that you are paying for is the 2 ports in Singapore and Hong Kong, but the L2 connection is only for the duration that you need, and the bandwidth is also only for the duration that you need. So it's fully automated, online, and you can actually further integrate Console Connect into any other services or your own networks today through an API, a very simple API. So again, one single port, and you can get internet on demand, iAccess as service, Cloud Connects, even do port to port, as I mentioned. Meeting places, this is where I mentioned if you are looking to connect to other ecosystem partners. Data centers, if you do not have your own data center connections, you can actually buy direct connects to data centers through us as well, right? And direct connect to software as a service or security as a service providers. So we can do this. There are 2 ways to do this port access. One is if you're already in a data center where we are located, it's as simple as a cross connect. All you have to do is buy a cross connect through us, or you can order your own. If you're a tenant there, it may be simpler for you to order your own cross connect, and you are already connected to our network. If you're not in the same data center as us, then we can actually do this via an edge port. An edge port basically means that we are extending that same port all the way into your own commercial building. For example, if you are looking to connect to your specific university or your polytechnic, we can actually deliver all the way up to the commercial building. I mentioned this earlier, which is the portfolio of our on-demand services. Again, a pictorial view. And further to add, we also provide multi-cloud routing as well. If you are actually transferring data between Amazon, Google Cloud, we are able to actually provide a cloud router for you to do that as well. Yeah, this is the cloud router. Okay, so you don't have to actually subscribe or purchase any physical devices. This is all done through our L3 cloud routing service. Yeah, so the internet exchanges again today. And these are all L2 direct dedicated L2 connections to the internet exchanges. We are doing a bit of IoT as well. We are able to actually provide the same connectivity through edge SIMs as well. So I would say one particular project that we did specifically in Hong Kong, where we were able to actually deploy SIM cards, eSIMs, to various shipping containers. If you can imagine, we actually installed 4,000 over eSIMs into various containers at the container port terminal in Hong Kong. And this was able to actually track some of the movements of the containers as well around the world as they travel. So if you can use that scenario in maybe a use case of your own, you can actually deploy eSIMs on your own networks today. And this is, again, a private connection. This does not go through the usual providers. We are actually having a bridge alliance. So we will actually carry this as a private connection to the Console Connect platform. Yeah. IP transit. This is where you actually utilize AS3491, our own IP network. And we are actually giving our universities today internet on demand. This is where you need bandwidth for up to 10G or even 100Gs in certain locations as well, and you need it for a short period or even a long-term contract. We provide this. This can be used as a backup to maybe the the ring system that today some of our Singaran's or Enran's or Geon's TNCCs are deploying today. This is a backup or a secondary solution. This can be used as in the sense that to supplement what you have already today, and it can be done also from point to point. That means to say, if you're speaking to one university, speaking to another university, this can be used as well, utilized as well. So I would like to end my presentation. This is a simple registration. All you have to do is get on board to consoleconnect.com, register. It's free until you actually subscribe to a single port. Otherwise, you can actually navigate through our platform today, take a look at the ecosystem partners that we already have, the logos that we already have, and see if these are of interest to you. If you are looking to connect to these partners as well, you can always have a conversation with me. Thank you.
Thank you. So, are there any questions or comments or requests or no? Oh, no. Okay, here's one. So you got the some kind of so-called the app store of the network service, right?
Yes.
So the some of the endpoint already have just some sort of the portal for the subscribers, let's say the university of the and the other research institutions. So so does the PCCW also the support for the integrates for those existing the service portal for this?
Yeah. Yes, we do. Yes, we do. On a consultation basis, you can always speak to me, and we can actually discuss and brainstorm with you what is the best way to go forward on this.
Okay.
Yeah.
Great. So if there's
so for your layer 2 port-to-port services, what kind of quality of service that you provide?
Yeah. Okay. So thank you. The SLAs that we actually provide are back-to-back with our own submarine cable SLAs, literally 99.9 onwards. So the standards that we deploy for our own networks today, which is the submarine cable networks or our IP networks, is the same SLA standard that will be given to enterprise customers or Enran's as well. Yeah.
Thank you. So then you'll be here for the rest of the week, right?
Yes.
Okay. So to communicate with someone. So
thank you so much.
Thank you very much.
Thank you.
Thank you very much. So so we got the first speaker of this session. Yes. And it will be the Park Rao from the union. So so floor is yours. Thank you.
All right, hang on. I'm running out of battery. Thank you.
All right.
Okay. All right, let me share the slide.
Yep. So it's been for around years after we got the last update from you. So yeah.
All right.
Yeah.
Okay.
Keep
Happy to be this one. Okay. All right. จอยเรียบร้อยแล้วครับ that's one. Okay.
Wait, there we go. So okay, there you go.
All right. Thank
Yeah,
you
please
so
start.
much. Thank you for your attention. And good morning, ladies and gentlemen. First of all, let me thank you all for coming here today. Let me introduce myself. My name is Pukao Sitthitawan. I am the Uninet Networks Administrator. And now we are Uninet. As can be seen from the screen, Uni is mean a university and Net is network. We combine together as the ones of the government agency. We come from Ministry of Higher Education, Science, Research, and Innovation. And now our main mission is to be a national information and communication technology resource management research center. Okay, all right. Our vision is mainly on the way we gonna improve the education, national knowledge sharing community, and using the network technology. Now we becomes aware the issue that we gonna solve the problem around the Thailand because we are the networks infrastructure that we connect all of the university in Thailand. As can be seen, our services is composed of three main parts. The one is the infrastructure, two is the connection, and three is the data. Now we combine all together and build the digital transformation from the university to be the smart classroom, to be the smart university in the future. All right, our services. Now we have the connection through the Asia Connect, but now at the current era, that at the moment we have 2.5 gigabit per second and a high-speed internet connection connect to the JGN is just only 1 gigabit per second. But now in the near future, the next year is going to be the 10 gigabit per second because we already have the discussion with Mr. Godo from JGN right now. And now the network multimedia, we have the fiber optic that connects all university in Thailand. All right. Okay, and the knowledge sharing, we have the ecosystem to have the database forms like the thesis, the research and education. We have our own software to provide to our university to have the medium of research and let every student can use like can come to us and access to the database and we can share the knowledge all over the Thailand. And now we have the cloud data center. We can provide the application layer to our university. As can be seen, we like the huge network infrastructure, like a data center, like a fiber connection. And now we can provide like a infrastructure as a services to our university. And moreover, the cooperation activity that we have built the strong relation between the collaboration allows the Thailand. This one, as can be seen, this is the overall network of the Uninet. Maybe it's internally from in Thailand, but now we provide international internet service at the speed of 200 gigabit per second and connect to the Asia Connect, right? Because we are the medium of the research center in the Thailand to connect to the internationals. But now We're gonna say that we have improved every year. That I gonna talk about the Uninet because now we have improved to the current state of us. According since 1996, we are the university network. We like a small network group or a university. Back to the past. Uh, the university all over the Thailand just have the collaboration to connect together. At that time, it's just only 2 megabit per sec to 10 GB, right? And we now have the policy to build stronger networks since 2010. Our university is 3,096 institute all university linked together with speed of 50 gigabit per sec. But now in 2 years, in the red one, we have the mega project we call NetNet because Uninet is the host of NetNet. NetNet is abbreviated from National Education Network. And since 2012, now we have the university connect together 7,606 university in that period. But now we continue to build and expand the network by the phase of this project, NetNet 1, NetNet 2. Now we have a NetNet 6. And NetNet 6 is next year, 2025. We're gonna build and expand the bandwidth to be 100 gigabit, 100 GB bandwidth, right? This one, as can be seen, we have the fiber optic network all over the part of the Thailand in the unit backbone network. We have 200 GB. As can be seen, we have 2 nodes to 200 GB. We have the core node 100 GB, 6 nodes. And aggregated node is 80 and 50, right? 80 and 50 GB is 6 and 10. And distribution is like a 10 GB, some kind like that. In average, we have 89 nodes right now. And we have the policy to build the infrastructure, and our near future we're gonna act as the software and the service to provide our university and provide them the infrastructure and the data center and the software and the service to the student. Right now, as can be seen, we have the node, right, that distributed allow the university, and they help. We have the community to share our connection and our knowledge sharing together right now. As can be seen, we have can you see the backbone? We have the fiber optic backbones that's as long as 13,000 kilometers across the part of the Thailand. And we have a distribution, and the fiber optic is 5,000 kilometers. And the last mile, 45,000 kilometer fiber optics that link the university all of the part of the Thailand and be together to share the knowledge and have the research community together. This one, moreover, we also have the cloud data center that's ready to be used for the student here, right? We can provide a virtual server computer service as known as the virtual machine. We can provide the VM to the government agency, to the university. If you would like to have the personal VM, we can provide to everyone like this. This is a spec, right? Specs of our infrastructure. This one is as can be seen from the screen, the Uninet office, right? We have our own server, our own data center, and ready to be used for the student. And this one, we have our own HCI. And this one, That's big. All right. Okay. Now for the Uninet, we are the ones of the government agency. We have our own products, but the thing is, the product is only to provide to the students, to the agent, to the another government agency. But now we just act as the medium of the research center in the Thailand. Now the Uninet, like, thank you for listen. Also as the Uninet is a university network, and thank you everyone to attend this class today. Thank you so much.
So, does anyone has questions or comments? No.
Okay.
No.
Thank you.
Oh yeah. So so I have one. So those kind of the generated image over the perhaps the machine learning and other things. So do you have any kinds of plan to install some GPUs on your servers?
Yep, sure.
Yes.
You can adjust the GPU. We can provide
Okay.
because they are the forms, right? And the form is the links to let you to write down your information, the GPU you would like to have, and the RAM and the data storage. Yeah, as you wish.
Okay. Thank you.
Thank you.
Thank you. So if any more question comes up, so yes, thank you very much.
Thank you,
Very
everybody.
nice. Yes, so the next speaker will be the Zhongfi and you. Yeah. Oh, yeah. Oh, yeah. Thank you. You're doing great. So for years. Yep.
Yeah. Hello, everyone. This is Bo Wang and Zhong Hui. We're from Tsinghua University and CERNET. Today, we will introduce our project, FITI, Future Internet Technology Infrastructure. Our introduction has 3 parts. And the first part will be introduced by me, and the next 2 parts will be introduced by Zhong Hui. Okay, what is FITI? The full name is FITI is Future Internet Technology Infrastructure. As its name has described, FITI is experiment infrastructure for verifying future internet technology. And this project is co-funded by government and 40 universities in China. And Tsinghua University in this project, we are the leading university. The main goal of FITI project is to build a large-scale and open research and experimental verification infrastructure to support research on major computer network science subjects and innovation on internet architecture and experimental verification for future internet technology. So why we design and build FITI? The main goal is to develop new internet technology, as we mentioned earlier. And so the main goal is to solve the major technical challenges in internet, such as the well-known challenges such as scalability, security, real-time, and others. To solve these technical challenges, FITI support and provide different levels of modification on existing architecture, such as we can modify the data transmission format and node forwarding mechanism and routing control policy of existing internet. So based on FITI, with these abilities, we can verify the feasibility of large-scale deployment of new network architectures. We all know that when we have a new internet technology, we have to deploy it on the real-world internet to testify whether it is effective. And with FITI, we can also verify what is the advantages of existing internet and which part is that we should to maintain and which part we should to develop new technologies. So we can verify the maintenance of existing advantages of a current internet, as well as smooth transition from current architecture to new ones. With FITI, we can also explore technical road and development of future network together with all the researchers all over the world. When we build FITI, we learn experiences from global R&E partners. For example, when building FITI, we adopted the structure of stable core network and combined with SDN overlay network. This road considers the helpful experiment and case from Internet 2 and Genie. FITI aims to take advantage of current network infrastructure and utilize existing academic network backbone like Internet 2 and Giant to avoid potential risk and lower capital cost. FITI is able to promote innovative development of existing network infrastructure, and FITI provide different layers of service for different function and different scale of network experiment. When building FITI, we making the best use of advanced and mature technology to build the experimental infrastructure. The general high-level idea of FITI is as follows. When solving the engineering challenges for scientific goal, our idea is to use mature technology. Mature technology to support experimental verification for future network architecture. And we also consider and follow the international trend and experiences. As mentioned earlier, we consider the experience learned from Internet 2 and Genie, and we also consider the global development tendency of IPv6. So based on those considerations, FITI's design idea has two ideas. The first is that we adopt and exploit IPv6 technology to build advanced and stable core network. We have mentioned earlier, our structure is to build a stable core network. And to take experimental verification, and we adopt and exploit overlay technology to provide diverse and flexible service. Based on stable and reliable core network, we provide large-scale and high-performance L2 and L3 experiment service. Based on constantly developing programmable platform and technology, we provide virtualization experiment service. The engineering goal of FITI is to meet the experimental requirement from future network research to build an advanced, open, flexible, international, sustainable, large-scale, and universal infrastructure for future network. FITI have lots of features. For example, feature employ native IPv6 core network over existing optical transportation backbone. FITI has 40 experimental nodes over 35 cities in China, so we can cover lots of different network environments. And FITI connected to domestic and international networks and future network test beds. FITI provide open and cutting-edge experimental environment. FITI also provide flexible multi-layer experiment service and programmable virtualization experiment service. FITI is able to support 4,000 different network experiments in parallel. So we can make different experiments at the same time. Okay, let's move on to the second part.
So thanks, thanks, Dr. Wang, for the background introduction. And now let me present the next two parts, the design and the implementation of FITI, which just, following the engineering targets of FITI as introduced by Dr. Wang. And then some typical experiments supported by FITI. And first, I would like to, through this slide, I would like to give you show you some major components of the FITI. The first is the optical backbone and the two-plane backbone, IP backbone. And then 40 experimental nodes, 4,096 heterogeneous experiment networks, and then international domestic exchange center, IVI transition devices, which can support the IPv4 access, peering, and experiment. And then two systems, resource scheduling and experiment support system, network management and security monitoring system. The experiment user and the real customer networks connected to FITI. Okay, then let's go through some details about those components. First one is the optical transport backbone of FITI. This is the topology of FITI optical transport backbone, in which we implement two optical transport links between adjacent FITI nodes, including the long haul, local loop, and the lease links. Based on the optical backbone, we design and build the IP experimental backbone. This is the topology of FITI IPv6 experimental backbone, which has 40 backbone nodes in 35 cities. Dual backbone link between nodes and the backbone equipment, including the routers and the transition devices. And over this backbone, we can also support the source address validation architecture. And on yesterday's network engineering session, we just got exciting news from SINET about a 1.2 terabit transmission experiment. And I believe, I also believe some of you might heard about the 1.2 terabit IP backbone link implemented over FITI backbone. Here you can see this link are joint developed by Tsinghua University, China Mobile, Huawei, and Sony.com, which is composed of a total transmission network spanning more than 3,000 kilometers, linking three cities, Beijing, Wuhan, Guangzhou, and integrated with some key technologies such as the co-router 1.2 terabit ultra high-speed IPv6 interface and the ultra high-speed multipath aggregation. And the implementation of those links over FITI backbone is try to provide the FITI experiment user with super high bandwidth for particular testing purpose, just like SINET, where we can try to get some giant data transfer experiment, and also as a verification and the trial for the 1.2 terabit technology developed by Huawei, and both of which are all the major goals of FITI project, as mentioned by Dr. Wang. And this is the internal topology of experiment node, from which you can see some more details on how we deploy two-plane backbone for FITI. One plane is named as the FITI-G, Here G stands for the general, which is focused on pre-configured layer 3 experiment and virtualization experiment. And the other one is FITI-S. S stands for special, which is focused on the customized layer 2, layer 3 experiment. Inside the node, each backbone plane has its own, as you see, it has its own core router, access router, and experiment router, and from the same vendors. Just as a major difference from the FITI-S plane, the FITI-G plane includes at the node include experimental side, which is composed of servers and switches. These two backbone plane is loose coupled to each other, which are interconnected through fixed exchange center only. And this slide can show you why we decided to build the two-plane backbone for FITI, because we can see some benefits of the two-plane backbone. First, we can try to provide the differentiated experiment service for different requirements from our users, and then maximize the efficiency and the consistency of interoperation, bandwidth allocation, and the experiment deployment across the node in different plane. And we can also provide more flexible for the different experiment operation mechanism and policy implementation over different backplane. And also we can try to minimize the potential impact and the interference of user experiment between two planes. This is the AS and IP address assignment for FITI backbone and fix. From this diagram, you can see in each backbone plane, there are one backbone AS and 40 edge network AS, and which are just for the local peering with user networks. And one thing you might notice, we have applied 4096 AS and 1/20 IPv6 address blocks for our user experiment planes. Here we can also call them as co-network slices, which make us capable to support 4096 user experiment in parallel with real AS and 1/32 IPv6 address block. And here, I would like also to express thanks to APNIC for allocating such a large number of AS to FITI project, and as well as gratitude again to our global R&D partners like APAN57, Internet2, and Giant, and so forth for accepting such a large number of AS announced for FITI backbone. Thank you. And now I would like to give a talk about one of the key characteristics of FITI user experiment plan implementation. As mentioned in previous slide, up to 4096 slides are supported in parallel over FITI backbone. There are three major types: pre-configured slides, customized layer 2 slides, and customized layer 3 slides. First, let us take a look at the pre-configured slides, which means the slides are pre-configured and deployed into FITI-G backbone plane as overlay networks for common experiment usage. We have implemented 2048 VRF white box and 2048 BGP black box slices as the pre-configured slice over FITI backbone. Besides the common experiment requirement, we can also support the experiment with some specific requirement by customized layer 2 or layer 3 slice. For the customized layer 2 slice, we use EVPN Sigma routing IPv6 and VXLAN for the layer 2 slice implementation. you can see as an advanced mode, we can also support the we can also introduce the virtual router into the layer 2 slice by creating the virtual router instance and connected to the layer 2 slice as an experiment user device, so as to provide more flexible experiment support to the user. Here we can call it as device as a service. And for the layer 2, customize layer 3 slice, we use layer 3 VPN cross-node VRF to provide the layer 3 slice experiment service to our users. This is a topology of fixed exchange center, which has 4 routers and 2 switches interconnected with 100G links. The fix maintains global and domestic peering with different type of networks, and it can provide the local exchange and global interconnection service to FITI backbone. The next 2 slides are the brief description of experimental side. Just like the FITI core nodes, the experimental side is also managed by resource scheduling and experiment support system, which I will mention later. It provides the user with computing and storage resource, as well as the virtual network inside the experimental site. These two diagrams show how the site resource is allocated, connected to the slice via layer 2, layer 3 VPN mode or VXLAN mode. And the combined mode is also supported by the VXLAN termination on side switch VLAN with layer 2 or layer 3 interconnection to the access router. Here we come to the resource scheduling and experiment support system, which more like a combination of orchestrator, controller, and experiment management system. Here you can see for the resource scheduling, it including the resource management, operation, and maintenance. For the experiment support, it includes experiment workflow management, template, and observation. These are the implementation diagram for the slice-based resource scheduling and experiment template handling. Just due to the limited time, I will not. I will just skip the technical details about the modules inside. So here, let me use an example to show how the slice-based resource scheduling works. As you can see, the slice in this diagram, the slice with green color, I think that should be green, right? The green color on the left stands for the spare slice, and the blue stands for the suspend status, which means it has not been deployed in the FITI backbone. And the purple stands for the used status, which means it has been deployed in the FITI backbone. Then here you can see 4,096 spare pre-configured slices and 3 experiment templates in this system. Now, first, we suspend 2 pre-configured slices, allocate them to template 1. And then we can deploy template 1 over these two slices. After the deployment of template 1, the experiment is ready to start. Likewise, we can also suspend another pre-configured slice allocated to template 2, and then get the experiment of template 2 online. And for the template 3, we notice it can meet the common requirement of pre-configured slice. So we just deploy the template 3 directly on pre-configured slice. And you can see now as a result, the slice changed to purple, which means the used status. When the experiment of template 2 is finished, we will release and return the slice to the preconfigured slice pool and restore the released one to preconfigured slice. And here you can see the slice change to spared status, which is available again for the new template deployment. Now let's come to the final part. In the part, I will give you a quick overview of several typical experiments supported by FITI. The first one is address-driven network ADN. And the key technology of ADN is two-dimension routing, which means the routing is based on both destination and destination address and the source address. For this experiment, we deployed the ADN routers over 13 experimental nodes over FITI backbone. The second one is space-Earth integration networks, which is the integration of satellite communication networks and ground internet. For this experiment, we implemented layer 2 overlay networks across 10 experimental nodes. The third one is the countermeasure study for internet infrastructure cyber attack, which is to evaluate the effectiveness of countermeasures for cyber attack over internet core infrastructure. And in this experimental network, we deployed 5 individual AS domains over 5 experimental nodes with global internet interconnection enabled. And that's all for our talk. And here we are really looking forward to the collaboration with our global R&D partners on future internet technology testbed. Thank you.
Thank you. Oh, thank you for the powerful presentation. I have to say, so it's kind of overwhelming. So the oh, are there any questions? Oh, keep again. Yeah. Oh, yeah. Here you go.
It's not like a question, it's like some query about the first of all, thank you very much for these wonderful presentations. I really appreciate the Research and Education Network also have this type of capability and they doing. I'm really appreciate on this part, right? I have one question regarding the, like you also mentioned the eVPN also implemented part, right? And do you have any experience with eVPN with different vendors like Huawei, Juniper, and Cisco? That means the vendor compatibility issue in the.
Sorry, you want to know the difference of the eVPN implementation mechanism? Or sorry, I can't hear.
Okay,
get
you mean
clear
like
understanding. Sorry.
Okay,
You
my
mean like
question is like
interoperability, right?
Yeah, interoperability
Yeah.
issues.
Interoperability other than Huawei or like.
For the interoperation issue, right? Actually, we know there must be some issue for the interoperational. So that's why you can see for the two-plane backbone, we say for each backbone we just select the same vendor for the same place. That's why we just as I mentioned, we just want to guarantee the interoperation and the coordination in the single plane. I believe that's definitely have some issue, but we just try to avoid. That's going to be maybe later we have some we try to expand the FITI backbone. Maybe we can try to do that, but that's not the main goals of the FITI backbone, because we just want to get the much stable core and provide more flexible support for the experiment. So we just try to just how to say, just try to avoid such kind of risk as mentioned by Dr. Wang. Yeah, thank you.
Thank you very much.
Any other questions? No. I just out of curiosity, how many engineers are involved in this project?
Actually,
like 1,000.
Actually, there is two major teams. One is for the the operation team and service. Because we are not just operate the backbone. We need also provide experience services to the backbone. So for this team, we have so far not too much, because because this background just come to the trial operation last year. So we are still trying to building the team for the operation service. But for the we have a quite strong research team like Dr. Wang, and they just gave they can carry out the design and also some security issue consideration on that. So for that, they just working part-time, not fully devoted into that. But I believe for the team, at least more than 20, I believe. For
just one university. We have 40 universities.
Yes, correct. Yes.
What
Just admission. Yeah, we have distributed team. Because for each node, we have a university. They just have signed a contract with us. They need to provide until five engineering to support the operation of that. So, but anyway, for Tsinghua University, the team maybe not as big as we expected now, but we have the big team just around all the countries through the 40 nodes. Yeah, 40 university. Yeah.
40 university.
Yeah.
For
40.
40.
Because we have 14 nodes. Yeah.
Oh, okay.
Yes.
That's a few hundred, right?
Yes.
Yeah.
We
Okay.
just try our best to get everything works well, but we still look, as mentioned, we're still looking forward to the collaboration with our global partner and try to learn more experience from our partners like APAN57, Internet 2 and Giant. Yeah, definitely.
Okay, thank you.
Thank you so much.
Thank you very much. So if not, yes, thank you very much. So the last but not least, the next presentation will be forward. So the here you go. So the you'll be hosting the next APAN, right? Yeah. So the what else? Do you have the there we go. Oh. Okay, yeah, please, thank you. Yours.
Hello, everybody. My name is Fawad. I am from Pakistan Education and Research Network. Today's presentation is just a brief about the PAN and its updates. So, what is PAN? Basically, we have connected the PAN is the Pakistan Education Research Network. 415 plus universities and colleges are connected with the PAN network. We have a 40 Gbps core long haul network. 10 Gbps is basically the last mile network we are running. 40 Gbps internet community traffic that we are providing to our customers, plus the R&D link from 10 is basically 2.5 Gbps that we are providing to our customers. These universities are, as you can see, the map of Pakistan basically are located all over Pakistan from Gilgit to Gwadar. It's all connected, and long haul is providing is basically in the next slide is 6,000 kilometer long haul that will be discussed later. So what is the evolution of PAN? How it was. So we have started with the 2 Gbps core bandwidth with the 64 to 128 kbps last mile connectivity with the 56 institution in the 2003-2005. Then it comes to the PAN 2 where we reached to 10 Gbps core bandwidth and the 1 Gbps last mile bandwidth with the 270 plus institution in the PAN 2 2014 to 2019. Then the last project that is will be completed this year. This is basically the PAN 3, where we have upgraded our core bandwidth with the 40 Gbps and the last mile connectivity with the with the 10 Gbps, and 450 plus institutions are right now connected with the PAN3. So the 100 Gbps core bandwidth upgradation is also on the cards, but it will take some time to upgrade the core bandwidth. We have 3 major rings basically distributed across Pakistan. Overall, it is basically 7,000 plus kilometer fiber that is when we lease from the different service provider, majorly Avateen, basically. Which has been connected throughout Pakistan. So it has been leased, not has been laid by APAN. Recently, we added the segment of Turbat and Gawadar. It was the very far side of Pakistan, the Turbat and Gawadar. So we have connected them with our PAN expansion. Also, we connected the Quetta from the Quetta and from Karachi and Peshawar. So it's all in the ring now. The whole provinces are in the rings now. Moreover, the ring 1 and ring 3, basically it was the longest rings we have in Pakistan. So we had divided, we bifurcate that rings so that the downtimes that we experience from the any cuts will be reduced. Coming to the services part of the PAN that we are offering to our customers, first of all, the concept basically that we are running in our PAN is smart universities. We call as a smart education through smart universities. There are 4 pillars that we have focused on. The first one is the smart bags, smart campus, smart classroom, smart assessment system. Smart bags is more obviously the giving them universities and student faculties with the gadgets, laptops, BODs, so that they can access the network, to have the tool to access the network. Smart campus means they have the resources, or they have the right tools to access the network through Wi-Fi or Wi-Fi network. Smart classrooms means they have the learning and teaching tools to have a experienced, innovative learning classrooms. With the and smart assessment means we have a learning management system and program learning objectives and course learning objectives also. So these are the basic services that we are offering. Basic service, we have the IPs and the internet bandwidth that we are offering to the customers. We call as a value-added services or advanced services that we are offering is basically the video conferencing, smart universities, EduRoam, e-learning, cloud, and all that we are offering. R&D service, that big data, e-culture, that our universities are doing with the help of PAN in different universities. So coming to the smart universities project that we have done, basically this is a project that done by PAN to establish the campus-wide blanket Wi-Fi coverage to almost 100 public sector universities. The reason was that basically in Pakistan there was something that universities can't buy such a heavy procurement and deploy the Wi-Fi setup or any kind of ICT infrastructure. So we supported them through our centralized project, and we deployed 20,000 APs in the universities and connected them through the Wi-Fi blanket network. Plus, we have also installed the 7,000 IP surveillance camera. That was a requirement from the universities to have surveillance cameras in the universities. So we provided them with the 7,000. It's all Huawei, basically access points, and the service, the IP surveillance is coming from the Huawei. So right now, 100 universities are connected. Again, we take the leverage of the Wi-Fi with the project of EduRoam. So 2016, we started the project of EduRoam with XApp. As you know, that we have deployed, we provided the necessary servers and the stuff. And earlier 6 universities joined the EduRoam project. Now we have 101 public sector universities that are on the EduRoam, and 2 private universities are also part of the EduRoam project. Going forward to the on the Indie-ROM area, we have now successfully have our own identity federation PKIFT, which is which we are on the member of the EduGain. This is a problem in the basically PAN that most of the journals and other stuff that was used on the IP base. So to overcome these things, we use the PKIFD solution or identity phase solution to reach these kind of resources and websites. So there we are a member of the EduGain also. There are 7 universities that has established their own IDPs, identity. They become the identity providers, and 2 mostly the services that we are using, that file sender and EduVPN, that we also using in the PERN. These another project that as I talked about is a smart classroom. Smart classroom that we have provided in 100 universities through the support of CPAC. We have provided to the 100 universities. Basically, what it is basically the interactive audio video conferencing with the auto tracking camera, so that teacher in the main classroom is teaching to the local students also, and interactively can connect to the remote students without any kind of human intervention and all that. It is own VDI system. It is own has a learning management system and all that. So these rooms are connected. So the unprivileged students that are in the remote part of Pakistan can connect with the main classrooms of the privileged areas of the Pakistan. So this project we have just recently completed, and 100 classrooms has been deployed, all connected to the PERN network, and hopefully that it will become it will also goes to replicate to many other institutions. In the smart classroom, we are also providing the virtual desktop facility infrastructure. Basically, again, if you talk about the remote Pakistan, there is a gap of the resources, electricity and data centers and all that. So what we did, the PAN is connected to the remote areas of Pakistan. So what we did is install the VDI systems there, and all the VDI systems are connected to our data center. So right now 3,000 VDIs are installed, with providing the 4 vCPU and 6 GB RAMs to the end user, with the 520 total terabyte memory has been deployed at the HEC data center. Talking about the video conferencing is basically we just have a video conferencing network or dedicated video conferencing for any kind of meetings and lectures. So in recent times, we have added the 37 sites into 2020 to 2023. The total number of sites is now 133 that are connected through PAN. And we did also different exercises like telemedicine, e-agriculture on the video conferencing through this technology. We have 3 data centers. One is basically in Islamabad, Lahore, and Karachi. It is already established data centers with different kind of capacities. The biggest one is basically in Islamabad, hosting 310 virtual machines of different kind of services, not for HEC but also for the universities. Lahore is also hosting the 80 virtual machines, and Karachi is hosting the 55 virtual machines. So these data centers has been exhausted. So we needed more data centers. So we built the prefabricated data centers in Lahore and Karachi just recently, with the total capacity of 480 racks that had capacity of 480 racks. Right now, we are in the process of deployment of the 80 racks, 14 Islamabad, 14 Karachi. The first phase of 40 IT racks is now operational, and second phase is basically completed in June 2024. So what would be hosting in these racks and why we need it is basically this kind of initiative that we have taken through a project of World Bank HETP, that we have provided the basic funding for the to deploy the high performance compute. We just finished the tendering process, procurement process, and it's now in the deployment phase, which will be completed in the June 2024. So we will be having the 120 teraflops and the GPU node will be 920 flops will be deployed in the Lahore data center with the 5 petabyte storage. So that will be deployed in the Lahore data storage. The next thing that we will be deploying in our data center is basically the cloud services cloud, the on-prem cloud, the educational cloud that we will be hosting in both Lahore and Karachi data center. That will be kind of a hybrid cloud. It has its own prem resources also, and it is also connected with the premier cloud providers like Amazon and AWS. Sorry, Amazon and Microsoft. So it will be connected to them to provide the facilities of the many resources, not locally, but if kind of sources not available or services not available locally, it can reach to the other service provider, other clouds also, to one billing system. So that's the idea that we are hosting in these two data centers. Plus we have deployed the e-learning system there, and it will be extended to 50,000 concurrent users, and it will be provided to the user through the SaaS model that we call a SaaS model. And it will be having fully components like courseware, quizzes, assignment exams, and all that we will be providing to all the university students. Last, that we are also hosting the Pakistan's first exchange point in both the data centers in Islamabad and Karachi. We are as a neutral body, we are hosting the Pakistan PKIX in Islamabad and Karachi. Right now, more than 20 carriers are connected, service providers are connected to the IXPs, and basically the monitoring and all the management are doing by the PAN team, and it's voluntarily doing for the cause of this IXP and the traffic locality. So, and the last thing is basically we also deployed the video conferencing soft client solution. Is basically we are taking from the MS Teams. More than 3 lakhs users are connected from our MS Teams. This is one of the biggest MS Team rollout solution that we are using in Pakistan. Not only MS Team, but also we are providing them with the Azure facility through Microsoft Education Transformation Alliance Agreement. We are providing them the Azure facility also with the Microsoft licenses also of Windows, Office 365, and all that. So these kind of facilities that we are providing to universities through PAN. And thank you very much.
Thank you. So, any questions? Oh, you go. Oh, you go.
For the new data center you've just mentioned, may I know what is the power can be provided to each rack?
Yeah, we design it with 12K.
20.
No, 12K each rack.
12 each rack. 12
Yeah, 12K
kW
each rack. Yeah.
Okay, thank you.
Any other questions? No. So, thank you very much.
Thank you.
So you are doing that from the ground to the up to the exchange point, right?
Yeah.
So so this is it for the network engineering session for this APAN57. So you'll be hosting the APAN57. Yeah. So I can go to the open mic, but you all want to have a lunch earlier, so I gotta finish here. And thank you for attending, and see you at Pakistan. Thank you very much.